All right. Hello, everyone, and welcome to this webinar about revolutionizing geometry import for acoustic simulations. My name is Jesper, and I'm a co-founder and the chief product officer here at Treble Technologies, and I'm going to be your host today. So I'm going to show you just here to begin with. See. All right, here is the agenda for today's webinar. We are going to start out with me discussing a couple of general considerations about geometry import and acoustic simulations. And then I'm going to talk about the current approach that Treble applies. Then we're going to be moving a bit more into the future here with a little preview of how we want to transition into using BIM models much more in Treble. And followed by that, a glimpse into Treble's future vision on this topic. Then I'm delighted to be joined by our good friend Pavel from Acoustic, who has been using LiDAR scans to speed up his acoustic calculations. So that he's going to be the star of the show. That's going to be very exciting to hear his case study, his kind of experiences with using this new technology for our use case here. So I'm looking very much forward to that. So the kind of the format of today will be that I will go through the presentation, and you can ask questions along or during the presentation. We will be addressing these questions later, however, in the Q&A session in the end. So both me and Pavel will be able to ask questions or answer questions, sorry, in this last part. So without further ado, I'm just gonna go straight into the presentation. So firstly, a little bit about Treble Technologies. We founded the company about 4 years ago, and now we're about a bit more than 30 people. Here you can see a picture of the team. Our mission is to enable a better sounding world. Essentially, however you're working with sound, we want to give you the tools so that you can work better with it and create value and create, a better sounding world for everyone in it. So that is underneath everything that we do, is sound and sound quality, and well-being as part of it. So how we're going to do that, or how we are doing that, is that we've built, our core technology is this Treble cloud-based sound simulator, which applies state-of-the-art technology to simulate or to emulate or predict how sound travels through the world, through air in most cases, how it reflects off boundaries and all these things. And we believe that we have the best technology to be doing that. And this is an engine that sits in the cloud, and it's scalable, and it uses the benefits of the cloud. About a year ago, we launched our first product, what we call the Treble Acoustic Simulation Suite, which is a front end to this sound simulator. And later on, we've added on this software development kit where you can access it more programmatically, and you could do more advanced things than you could do in the user interface. But the user interface has been more or less targeted towards these use cases of engineering acoustics and in the built environment in particular. And that's also going to be today's focus. So we're going to be focusing on the Treble Acoustic Simulation Suite for engineering room acoustics in the building industry. This is where some of the things that we built is more focused on. It doesn't mean that it cannot be used for other things. It has a wide application. Geometry import is, as I'll show you later, kind of a key part in doing any kind of modeling. You need to have some information about the room of or the geometry that you want to propagate sound within. But some of the things here is perhaps focused on the building industry. All right. To perform an acoustic simulations, you need 3 ingredients to this dish. One, you need a geometry. And not just a geometry of the building or whatever you're trying to simulate, but a model of the air inside where the sound is propagating. And then you need information about what materials does this air volume bound up against. And lastly, we need information about what kind of sound emitters and sound receivers is in the space, so loudspeakers or people generating sound, and then also kind of how do we want to listen to these sounds as well. Today, the topic of the webinar is geometry, so we're going to focus almost solely on this first part, and probably we're not going to be running many simulations in this demo today. Even though that's of course the purpose of the whole thing, is to predict how something would sound. Okay, so kind of focusing in on the building industry. So today, in most cases, in most places, this differs a bit around the world what an acoustician or acoustic engineer is. But this person is a part of the building industry, or a part of the building workflow of designing new buildings. As we see here, that's one part, and also the refurbishment of other buildings, or like trying to improve how a building sounds. And the geometry that is coming from these two different, how the geometry is prepared, depends a little bit on these two different types of projects, essentially. It's quite obvious that when the building is a new building, then you don't have a real building where you can go and do measurements. But in many cases, you have some information in the form of a 3D model, or if it's very early stages, at least some sketches of how this building is going to be, so that you can make predictions. Because it's impossible to make predictions about how something sounds if you have no idea what it is, obviously. Okay, so let's zoom in on what this geometry could look like. Very often these days, and in many parts of the world, whenever something is being designed, or even when something is being refurbished, there exists a 3D model of the tool, not of the tool, but of the building. This also applies to these renovation projects. And very often these 3D models have been prepared very early in the process. So that you have some kind of 3D model already in the kind of sketching stages of designing a building. And as you can see here, these building models, they can be very complicated and have a lot of details and information also about what is the different materials that are there. So there's a lot of information in these. I'll get back to that later on. Another way that we acousticians often get this information is that we have a plan drawing, and this is of course often in, like, when you're refurbishing old buildings, you have a plan drawing, or the project is perhaps not something where we really need a 3D model to do the work, at least from the architect's perspective. But then you have plan drawings, which explains how the building looks, and from that we need to then generate something we can predict the acoustics from. And lastly, I would say, like, you can also end up in situations where you don't really have anything except for like sketches and ideas about the building, and in some cases you have just the actual space, and that's something that Pavel will be talking with us about later, how we can then use this new technology or new emerging technology of LiDAR scanning to then easily get to a point where we can get a geometry from these spaces, so we can work further in the modeling domain with the acoustics. So when we do a model of room acoustics, or a simulation of room acoustics, a general thing is that we don't really need a model of the building itself, like the bricks and mortar and all of the physical things inside the space. But what we actually need is a model of the air inside of the space. So we don't care about the exterior surface when we're just modeling the inside of a living room, for example. And that's one of the kind of fundamental problems that is posed to us when we set up these simulations. Another part is we don't need a lot of details to be able to run an acoustic simulation. It kind of just gets in the way because there'll be many more surfaces to apply materials to, and in some cases it can also slow down your simulations. So what we are proposing is that the models look something like this, and details that is not relevant for the wavelength that you're modeling is left out of the designs. So in this case here, the chairs have no legs because the legs are very thin, and sound waves will simply propagate through, as well as table legs, for example. But how much detail you should simplify away depends a little bit on, or depends fully on what is that you want to model in the space. We're currently working on some application notes that will give you a bit more details in how we see this the step of simplification. But for now, you can definitely look at the examples that we have here. So, and some additional considerations for Treble, because we are applying wave-based analysis, we have some more strict requirements on the model being watertight, and we've developed some tools to help you do that, but that's a prerequisite when you want to do wave-based analysis in Treble. You can still do geometrical acoustics, which is a key part of our offering as well. But we believe that most of the value gets unlocked when you go into the wave-based analysis. Additionally, we would like to, see simpler models than usually these BIM models end up being. So, because the small geometrical details can really hurt the simulation time of the wave-based analysis, in particular. So these are some additional considerations that we have to do when we do simulations in Treble, and I'll get back to these two points later on. So when we're in the process of doing an analysis of a building or a room, a space, then we have some different approaches on how to get to this acoustic model, and one of them is that we can take this fairly complex BIM model, and here's an example here of the this is a standard model in Revit, where you can see you have buildings of the you have models of the trees outside, and you have a full model of everything that's related to the house, and then you can start trimming away until you end up with this interior shell of the house. That's a very tedious process, and it can take a while, and you're not really actually sure that you end up with a product that is good for acoustic simulations. We've also seen people, heard about people having like very specific tool chains for running these some existing simplification techniques out there, and some of them are fairly complex and involves maybe 5 to 7 different steps in running it through different types of plugins and tools. And it gets the job done in many cases, and people develop workflows around it, but it is also very complicated and not very accessible for everyone. Another approach is that, and it's something that we see very often, is that you simply remodel the space from scratch. And this works very well with plant drawings as well. You can draw on top of plant drawings and extrude them out into the section drawings as well. And but it is very time consuming, and we believe that kind of the last step here is what in too many cases ends up happening, which is that you simply just skip doing the modeling because it's too difficult to get from information about the model to acoustic model. And there are of course a lot of acousticians out there that where this is that has the experience. They don't need to do modeling in every single space. That's clear. But there are also cases where a model would have benefited the end customer and would have predicted some issues that could have been easily treated earlier on. And it also kind of plays into the part of moving this whole process of doing the acoustics design earlier into the process of the building, so that the architects designing the buildings is able to get feedback on the designs at an earlier stage. And that's something we would very much like to see the industry kind of tend towards, but we just need better tools to be able to accomplish this. And we've already, with how Treble is set up today, built some better tools but it's still working in the old way of working. You're still responsible as a user for building an acoustics model. And we've built the SketchUp plugin that we have today and that we're very proud of, that helps you sew up the geometry into something watertight. It tells you if there's a hole in the model. It tells you if some of the parts get excluded from the model because they're outside of the shell that you presumably want to do a model on. So we've gotten pretty far with this, and I hope you guys are kind of agreeing and enjoying working with our SketchUp plugin. One of the things that we've lately introduced is the ability to also use other tools, and kind of having the same tooling that is available for you in SketchUp to see where the model is not watertight and these kind of where the problem areas are, just with a direct file import directly into Treble, enabling 3DM, DXF, and OBJ as import formats. Even though this is still in beta, it's something we've gotten very good feedback on as well. I would like to have done a demo here, but I know that Pavel is going to do exactly that demo where he's integrating Rhino into the workflow. So I'll leave this one out for now and leave that to Pavel. That's going to be great to see that. What we would like to see and what we would like to support is the transition into using these BIM models directly. And then the first question to answer is what is BIM? BIM stands for Building Information Modeling, and the concept of this is that the model represents what we call a digital twin of the building. So that means that it's not just kind of dumb geometry that represents how the building looks, but there's much more information embedded into the geometry and into the kind of the different elements of the design, of the information. And the whole concept here follows the building throughout its life cycle. So from the early stages of design, the first kind of lines gets drawn into a BIM modeling tool, and when you then decommission the building afterwards again, then you know exactly how the building looks and how you should do it because you have a 3D model of it. And of course, whatever comes in between, like the kind of later stages of design, sharing information between the different disciplines, and in the building process as well, that you can instead of you can directly pull out how many screws do I need for this to build this building. And it has been a very successful journey in kind of for many disciplines to adopt the use of BIM throughout the kind of the industry. But one of the places where it's still lacking is the acoustics discipline. And that's what we would like to take a step in towards enabling. So for us, the near-term goal is to enable direct import of BIM models into the Treble tool or into the Treble platform. And for this to happen, we have identified that we simply need to apply some acoustic simplification or some automatic simplification, which will significantly reduce the amount of manual steps that's needed to get from a BIM model into an acoustic model. And this is again kind of the whole concept of modeling the air rather than modeling the building elements themselves. So we've come quite far with this already, and I will demo some of this later for you, how that looks today. And by enabling this for us, we're from our side, we want to enable the acoustic engineers to integrate better into the AEC workflow, and become Treble should become the kind of gateway for acoustic professionals to start using BIM. And the first steps for us in this is to enable what's called an IFC file to be imported directly into Treble. And then I guess the next question is, what is IFC? So IFC stands for Industry Foundation Classes. It's an open source format that facilitates exchange of models and information in AEC. So it's a format that kind of goes across all these BIM modeling tools and 3D modeling tools in the AEC industry. It contains a model of the geometry of of a whole building in many cases, and then it contains all the data as well that is kind of attached or kind of related to the building elements. So there's a lot of information in there, and that's one of the problems. That is in just kind of taking the IFC and throwing it into Treble as is. That would simply not work. We need simplification, and we need to choose the right information. And we've spent a lot of effort and to get to a point where we feel like we can generate something that's close to an acoustic model. And one of the steps here is of course, as I mentioned before a few times, like we don't need building elements, we need the air inside to be able to run our simulations. All right, so next up, I would like to give you a live preview of what we have been working on at Treble for quite some time here with the IFC import. So for that, I'm going to jump over to the Treble app. And here this looks more or less as usual. But what is different here in this version here, the preview, is that when you click the import model here, there's a tiny difference here, is that we now have the support to import an IFC file. So I've prepared a test house here that I'll just find. Here we go. And it is as simple as kind of just taking this file and dragging and dropping it into the window and clicking upload. All right, and meanwhile this upload is happening and the processing of the file, I'm going to just show you guys what is actually in the file. So the IFC here is, in this case, it's just it's a test model of a house, the Treble house here, or something we concocted to make a rather simple test case for you to show you guys. So we can see here this model consists of 2 different building stories. And if I fold these out, I can see the different spaces that is included here. So we have here the studio space. This is the one behind here. We have a small bathroom space here, and then we have the big kitchen and living room with all the furniture in. And on the top floor here, we have some spaces as well. We have a bedroom, and here for this purpose, we've filled this space with some chairs, and we've also created some curtains here. Some things we often see in these IFC models, that you have these types of details in there. And then we have a couple of more rooms here, and as you can see, the kitchen and living space and this attic space here is actually coupled by this staircase here. Let's see if I can find it. So the staircase here, and then we've added a couple of different pieces of furniture into the room. This is not a very complex IFC model, but these are mostly for demonstration purposes, just to show you guys how we feel like these elements should be simplified and what kind of processing will happen when you upload a file through Treble. So we have the kind of furniture inside the room, and we have these window panes here. You can see that they have quite some detail, and of course the staircase here has the railing and the stairs in there as well in the details. If we zoom in a little bit closer here on this, you see you have a lot of small details around these chairs here as well. So this is what we're looking at, and what we would like to make from this is, of course, again, not a model of the building elements themselves, but rather a model of the air inside of the space. So let me just switch over to the Treble app. Let's see, this is finished. Yeah, so it is finished uploading. So what you see here in the Treble app now is a new window for showing the feedback here and what you want to import. So first off, you see here that you should select a new space to put in your models. And here I'm just gonna create a new test space here. Test space. Then I can choose what all the models should be called under each. I'm just gonna say this is my initial model. And then when we go down here to the space browser, you can see that we can select these different ones here, and you have some different logos here showing that there is some warnings to these, which is very related to what you would see when you upload another file, or when you're in SketchUp. You see these different different things here, like short edges that could tell you that there might be some things here that would require your attention. It's not necessary, necessarily necessary, but if you find that the runtime of the simulation is short, is long. What else you see here is, like, on this side here, you see what kind of layers your geometry got separated into. So here, this one has the basic wall. It has a floor here, which is also the ceiling, because the floor was kind of dividing the space. We of course have the floor of the actual space, and then we have the windows and the doors. And one of the details here that's good to look at is that the details of the windows, which looked, if you remember correctly, then we have a lot more details around these windows, and this has been simplified down to more of an extrusion in from the space. So this is a rather simple space, and this turned out to be a watertight space that you can then run a simulation on. And this is a fairly decent acoustic model, I would say. So if we then look at some of the more detailed case here, if we see this kitchen and living space, let's see if I can find it here in the browser. Then we see that, of course, that the space got extracted. So you have only the interior walls of the space. You will see furthermore that the windows, of course, also got simplified down. What you additionally see here is that we removed the railings of the staircase, and these complicated chairs that we had before got simplified down to simply 2 surfaces for each chair. And also this furnishing here, if we look a bit closer onto this, you'll see that you have a lot of triangles and a lot of details around these, but these got simplified down to simply boxes and a boxy version of this couch. And this is now ready to run a simulation on, and run a wave-based simulation on as well. So once, let's just have a look at here this master bedroom with all the chairs. And what happened here is that the curtains got simplified down to just a box, and you can have all these chairs here that got simplified quite a bit. There's just 2 surfaces here. But the crux of it here is that we have these different spaces separated out, and the next thing I can do here, if I'm satisfied with this, is I can simply import these spaces. And once this just processes for a little while, you can see here now in my homepage, I get the project, which is called test space, and then I get all the spaces from the IFC file put in here separately. And now I can go in to my kitchen and living space here, for example. Then I can start running simulations on it. Start creating new. Let me just open it up to show you guys. So creating a new simulation, initial simulation, and then I can start assigning materials to these layers that got extracted from the space. All right, but if I go back here, one thing I can also do, if I'm not completely satisfied with the result that got out, I can also go to the space and find the model here. And if I click the 3 dots, I can download the source model, which is a DXF file of this space and not the IFC file itself. So I can continue then in whatever, in SketchUp or in Rhino or in whatever kind of 3D modeling tool I want to use. I can pull this in, I can make the changes, and I can upload it again straight to this model, so that you get another iteration here. So we're kind of enabled to use this as a starting point to move on further. So this is what I had for the preview. Let me go back to the presentation here. So the next steps here is for us. Now this was a test model, and of course whatever is out there in the wild, or IFC files and files that you want to get imported and you want to generate acoustics model from, can be quite different from this one. So the next steps for us in this process is to start getting your input as a beta version of this feature. So In this case, we're not gonna make it public to anyone, at least not in the beginning here. So we would like you guys to sign up for a beta if you're interested in getting access to this and kind of developing this feature with us. So down in the bottom here on your screen, you should be able to see a sign up formula, and we will also get a what's it called, in the follow up material from this webinar. You will also get an option to sign up for the beta. So please do that if you're interested in this, and we hope to work with you on getting this feature just perfect. All right. So what we want to achieve in this kind of near term here is, we do this as a beta release because we still need to tune and improve this feature, and we need your help with this. And hopefully, we will get to something where everyone feels like, okay, this is a very useful model that comes out. And that part of that is, of course, improving the robustness of how a service like this runs. And hopefully in the coming months, we can move on to a full release of this feature, kind of giving everyone the benefit of having this. So a key thing in a feature like this is that it is robust and it gives you results that you can count on. And therefore the beta release is the right way to go, we feel, for this. So I hope you guys, more than most of you are interested in kind of signing up for this and helping us through this process. That would be very much appreciated. Right. So if we then talk about kind of a glimpse into the future, what comes after this. So the first step here after this is that we're going to work on, I would almost call it, tuning and improving this feature even more, but also kind of adding more advanced processing onto this, with the goal of ending up with a fully automatic acoustic model generation. And this is something that we already have put significant efforts into, and we have a path forward that is going to get us there, we believe. But this is going to take some months for us to fully get this ready. And what this allows us to do, then once we have this fully automatic acoustic model generation, is that we can set up and run simulations on multiple spaces and whole building projects in one go. So you simply drop in your IFC file, and you can see all the spaces, you can identify all the spaces within it. And once you then choose to import whatever part of the space you want, then you can in bulk set up the materiality on these spaces. You can choose which type of analysis you want to do. If it's a reverberation time study, then we will populate these rooms with automatically with sources and receiver pairs that makes sense for this kind of a space. And the idea here, the vision here, is that you will then rather get just a report of how the whole building performs with these materials you chose, and which spaces need special care and which don't. And that's one of the things that we're really excited about moving into in the future. And I would say kind of after this, then we will move on to integrating our tools, or our tooling here further into the BIM workflow, which means plugins into BIM tools. And then it allows you to do more like two-way communication between BIM, so that you can get your results back into, for example, Revit, and it becomes much more integrated into the workflow. Also, not just seen from the acoustic engineer's perspective, but from the whole building processes perspective. So that's an exciting part as well. Then I would say, kind of on the side, the data collection part of things is very interesting, and I think I was very inspired to see how Pavel is using Treble and using the new technology of LiDAR scanning to easily get to an acoustic simulation. This is one of the things that we're really excited about enabling further into Treble as well, so that you have even better workflows related to scanning rooms. And then integration into more kind of architectural tools such as Grasshopper, which where you can run generative designs and you can see what is the effect on the acoustics when you do 10 or 15 or 100 iterations of a room. That's an interesting path for us as well. So this is a glimpse into the future of what we want to achieve, and this is going to take us some time to get there. But we hope that you guys are kind of inspired to tag along for the journey. And as I hopefully already showed you today, you can already do a whole lot with Treble as a platform, and get fairly quickly. You have the right tools for the job, for your current workflow, in kind of getting from whatever your geometry looks like into having set up acoustic simulations, predictions of how the sound propagates, predictions of room acoustic environments, and also these listening experiences, which I hope hopefully all of you are familiar with, that we feature in Treble. But without much further ado, I'm going to just leave the stage for Pavel, who's going to talk about LiDAR scans to speeding up his acoustic calculations, and this is going to be very exciting. So thank you, and we'll see you later at the Q&A.
Hello everyone, my name is Pavel, and today I will tell you how LiDAR scans can enhance and speed up your acoustic calculations in Treble. I'm Paweł Kowalik, and I'm Technical Marketing Manager in Acoustic in Poland. I also work with innovation projects with our headquarters in Sweden. That's why we were very interested in Treble. Acoustic is acoustic solutions manufacturer that is present on the market for more than 40 years. We've been part of the Treble's journey from their very beginning. We observed the company because we knew that software they created can improve a lot our daily work. In Poland, we started in July 2023. And the first thing we have done was a benchmark that compared the regular acoustic calculations that we have done before using Fitzroy or other equations, and our internal tool Beam2AAC and Treble. Results we received were very optimistic. That's why we continued the work. So far, we calculated 15 projects, and to do that, we created more than 50 models and we calculated them. We also had an experience with real measurements that were done on the projects that we simulated before in Treble. Today, I will elaborate more on LiDAR technology and how it can improve our acoustic calculations. One can formulate a vision that every single person that walks around the street have 3D scanner in their pocket and can do whatever they want to with every single room, like visual rendering of refurbishment, like acoustic simulation after acoustic adaptation, and a lot of other things. Actually, we are not that far off that vision, because I can assure you that many of your colleagues, and maybe even you, we have 3D scanners in our pockets. LiDAR technology is present on the iOS Pro devices, and if you or someone in your neighborhood has this type of tool, you can start your 3D scans. I will show you how to do it by example. You just use your tablet or cell phone and you start to scan. You find a ceiling and the floor, and you see your scan is started. You see white lines on the screen and they mark where your objects, walls, doors in your room are. You receive model like that, and yeah, you can do different things with him. Today we will tell about the acoustic simulations. It is not ready yet to be transferred into Treble, and that's why you need to adapt it a little bit in Rhino. In this movie, you see how to do it. You just have to explode polysurfaces because objects that you receive from this scan are created in polysurfaces. So you explode it and you remove those surfaces you do not need. Here is an example how I do it with the walls. And after this job is created, I join the different areas, different surfaces in every single wall. And I have a shape to start with. I have to add other layers in my model for ceiling, for floor, for doors. And that is something I'm doing right now. Afterwards, I have to create the surfaces that are missing in my model. As you see, the floor is missing, the doors are missing, windows are missing, and the ceiling is also missing. So I have to create those surfaces. After I created ceiling, my model is watertight, and I'm sure that when I transfer it into Treble, the wave solver is enabled. And I have to deal with the other objects like cabinets, desks, chairs. So I do almost the same job I have done with the walls. So I explode it and I just remove surfaces that are not necessary in this model. I adjust them a little bit if they are not in the same place I wanted them to be. Yeah, and my model is ready. So that's really simple. And you need, if you are skilled in 3D modeling, you need like 10 minutes to do something like that with this simple model. I import it into Treble using this import geometry function that you have from the beginning of the year. And I can start with the pairing materials, adding sources and receivers, and all the things I can done in Treble. First project I started with was a sport hall in my city. I felt like Neil Armstrong taking a first step on the moon, doing this scan of this room. This room is very reverberant, and I know that the children and the other people that are using this sport hall, they do not hear, they do not understand the full trainer or teacher communicate. So that's why I also thought that this is the very good example to start with. First thing I have done was a LiDAR scan, and I spent around 10 minutes doing that. And I've also had conventional methods of doing measurements like laser scanning. And you see that the accuracy I received is around 10 centimeters. So yeah, I know at this step that it is really wise to continue because we will receive very accurate geometry. I came back to my home and I opened Rhino application in my computer and I adapted this model. That was the first time I used Rhino, so that's why it took me 35 minutes. And I had also to add some of the things that were not scanned, like the ceiling beams and stuff like that. And you saw what you have to do during this process. And I imported this model into Treble, and all the things I have done here, it took me 15 minutes. I mean, pairing materials, adding sources and receivers, and I also create a surface receiver in here to show STI how it spreads, how it looks in this project. So, and I had also opportunity to create our realization, and because Treble allowed us from the beginning of December to share our realization with others, I could send my realization to the people that were interested in that. I've created two different scenarios, acoustic scenarios in here. So on this chart, I show you empty room calculation for the existing room, second scenario with only acoustic ceiling, and the acoustic ceiling and the wall panel scenario. I've also wanted to show you how STI looks in this project. In this existing state, we see that STI is somewhere around 0.3, and we know that people that are using this room, they understand only around 30% of the communicate from the spokesperson. And in the last scenario, in the second scenario, we see that we are somewhere around 0.7. So we improved a lot communicate understanding in this room when there is acoustic adaptation in here. So that is something very convincing for our customer. I've also created our realization in here, and I shared it with customer all together with the results I received. After this model, this first project was created, I wanted to go farther with something bigger, with bigger office. So that is why I've scanned part of the big office with the open office area, with the different rooms like conference rooms, office rooms, and I've chosen two of them to create acoustic adaptation in here. And I've also had an opportunity to do real measurements in those rooms to compare how they look with results that we receive from Treble. That are my model that were created and adapted in Rhino. And here we see results from one of the rooms, and you see on the chart the orange line and blue line is really parallel to each other. So we see that the results that we received from Treble, from acoustic simulation, and results we receive from real measurements, they compare in pair. They are parallel to each other. And that was another proof for us that results we receive from Treble are very accurate ones. I want also to underline that every single room that I have created and work with, it took me about 1 hour to do full acoustic simulation and also our realization in those rooms. So it's really short time. What do you need to start with your first LiDAR scans. First of all, you need Rhino app on your iOS Pro device. So even if you are not an owner of this type of device, I am pretty sure that someone from your neighborhood has it. This app is freeware, so you can start and do a lot of scans. Afterwards, you need a Rhino app on your computer to adapt the model. And thankfully, they have 90 days period of trial. So you can install it and you can be happy to use it for 3 months. When your model is adapted, you obviously have to transfer it into Treble. And if you are not an owner of the Treble license, you also can use a free 30 days trial period. So as you see, nothing stops you from starting to do these LiDAR scans. What you can receive using LiDAR scans. Your work during your acoustic simulation is shorter a lot because full acoustic adaptation for the one room, it can take you 1 to 1.5 hours or even less. It depends how skilled you are in Rhino. You receive very satisfying results from this scan because accuracy, as you saw, is about 10 centimeters. I have also underlined that the Rhino works very well with Treble, and they come pair in pair, and the models that we receive from Rhino, they fit very well into Treble calculations. Just to summarize, LiDAR scans can save a lot of time and they can improve a lot your daily work. If you have any questions, I will wait for you in this Q&A session, and you can come back to me with any single question you have. And you can find me on LinkedIn. And yeah, I'm really curious about your first experiences with your LiDAR scans. And I'm really happy if you want to share them with me afterwards. So yeah, you can come back to me. But anyhow, that's all from me, and I'm waiting for you for your questions in this Q&A session. See you soon.
All right. Thank you, Pavel. That was great.
Thank you.
That's the end of the kind of official webinar from our side. So now it's time for the Q&A session. So we've already received quite a few questions here, as you can see in the questions below. But if you have any more questions, or you want to upvote some of the questions that already have come in here, please do so. We will be available here for the next about half an hour. So there's plenty of time for more elaborations and discussions. All right. I'm just going to start from the top, or maybe from the bottom of the questions here, the oldest one first, and then we'll try to just go through all of them. So, or do you have any remarks, Pavel, on something you want to add?
Not for now. Maybe we can go through the questions, yeah, because I see a few of them, yeah, several of them. So
exactly.
Let's go.
Okay, let's go. So first question: did Treble do all that simplification by itself? And to that, I can answer yes. We have tried to apply some different simplification schemes to get the job done here. One of the good things about IFC is that you have these different categories for different types of building elements. So, for example, furniture, they usually get placed inside of the IFC furnishing element category, which means that we can specifically filter these out and then run some more elaborate processing on these. As you saw, for example, the chairs, they got simplified quite a bit and ended up as just two surfaces or two quads in there. but this is one of the things, we know that it works for these chairs. I'm sure that there are chairs where this doesn't work so well, so this needs to be tuned and tweaked. But like I also mentioned earlier, it's all about getting to the starting point where you guys can easily kind of go from this on to the model that you need. All right. I hope that answered the question. Please follow up if there's anything else that I should elaborate on with respect to this. All right. The next question here is, will a recording be available later? And I think we already answered this here. Everyone who's signed up for the webinar will receive a recording, but there will also be this sign-up form to participate in the beta. All right. Another question here. So each space needed to be watertight. Does that mean that the spaces below and above the staircase are seen as one? In this case, yes. There are some different, I would say, almost like schools of thought in a way. Not schools of thought, but like different ways of modeling it in IFC. And there's this category called IFC opening element, which usually separates these things when you have doorways that are open, like big doorways, and when you have staircases like this. But by default, in the way we've set it up now, then anything that's connected by air will be one space. And as you saw, we merged these two spaces into one. The reason for doing this is that you often see these, spaces that are actually not spaces. They're more like annotations of what is the purpose of this side of the space and what is the purpose of this side of the space. So, and the normal example here is that, you have a kitchen and a living room, which is one room, but it has two purposes. So they get flagged as two different spaces, even though they're one. But we intend to kind of explore whether this is what is needed in terms of customization with respect to this. Okay, and on to the next question here. Let's see if something got done. Oh, here we go. So this is a question for you, Pavel. And can we imagine using LiDAR on a larger room, such as theaters, for example?
Yeah, you've seen because I've seen this question popped up when I haven't mentioned yet when it comes to this open office area you have seen, in my presentation. And as you see, it is possible to scan larger rooms, like very large ones, when it comes to surface of the room, but not the taller ones, because this application is not made for the rooms like I don't know, 12 or 15 meters of height rooms. But you have seen also this sport hall. It's quite tall. It's something around 6 meters when it comes to height. It was really good when it comes to scan, but it always has limitations because when it comes to extraordinary rooms, like not rectangular ones, this app does not work too well. With this, it tries to simplify the geometry. It's not so convenient. You have to do a lot of work in Rhino afterwards to adapt this model, for your purposes. Mm-hmm.
Interesting. Maybe a quick follow-up on this. Have you tried any other devices, that is not a phone to do LiDAR scanning?
Not yet. No. Because I know that there are very complex 3D scanners, on the market, but they are quite expensive ones. And this technology is something that we have in our pockets. That is really that everyone from us can have it, has access to that, and we do not need those really complex softwares to use that. So that is something that I focused on. I haven't tried those complex ones yet. Okay.
Here is another question. Unfortunately, not every smartphone has a LiDAR scanner. Only the iPhone Pro. And the user here is commenting that you're not sure about Android. Do you know if any Android phones has?
No, not yet, not so far. I've seen that only these iOS devices with Pro, like iPad and iPhone, and they have it. And yeah, it works only on those.
Okay. All right. Next question here, also for you, Pavel. People are very excited about these lidar scans and your expertise here. So, what reactions have you had from using this lidar technology for acoustic simulations in your workplace?
Yeah, it's like when you start to do this scanning, everyone is looking at you as you are, I don't know, from the future, like a guy from the space, yeah, coming here and doing scan. It really makes impressions for the people. And when I show this technology to the people when on presentations, they just take out their phones and they trying to download this app and try to scan the rooms. This is not aware of yet, yeah, but this technology is with us for quite a time, yeah. So, but it is up to us if we use it in a proper way, yeah. That's that. But it is really good to know that it is not so complicated. It is not so complex to use that.
Okay, yeah. I think you're paving the way here to kind of show that this is not, this is exactly like it's in our pocket.
Yeah.
So we should really try to use it. All right. Next question here. Isn't using SketchUp or other 3D modelers for adapting the lidar scans possible? Or also possible?
Yeah. When it comes to lidar scans, I use iRhino app, and it can give us a model in a 3DM format, and it allows us to import it into Rhino. Yeah. Yeah, we could use Rhino and transfer it into SketchUp and afterwards do the geometry in here, but it is not so efficient way, I would say. And right now, when we have this access, when it comes to Treble, yeah, when we have access, when we have possibility to import 3DM model just directly from Rhino, I see that it is different way to work with the models, but as efficient as with those models from SketchUp. I think like Rhino works very well with Treble. Like these models import very fast, very accurate, and this communication between the model and the Treble is very well. When the model is not watertight, Treble helps you, like it is shown in a very good way that where this non-water tightness is, like, when the surfaces does not meet with each other. So it's good. And I think this is the best way for now to use this Rhino software to do that.
Yeah, I also personally have very good experiences using Rhino as an addition to SketchUp. It's just a little bit of different way of modeling, but it has some very powerful tools built in. For example, like you mentioned here, the importing of these types of data.
Yeah, and when I can add something, like we here in Poland, there are two people using it, me and my colleague Alexandra, and we are in totally different we see it from the two different perspectives. She is using SketchUp and she wants to use SketchUp, and when I see SketchUp, for me it's too general and I want to use Rhino because yeah, I prefer to do it in here. Yeah, because I see Rhino is far more precise. Yeah, like the surfaces meets in a very precise way, and it is very, yeah, for me it's very well to work with Rhino, even with the models I create from the very beginning, not especially from the lidar scans, but from the very beginning I also use Rhino.
Yeah, very good. Okay, next question here. In Treble, given source receiver pairs, can I get room impulse responses as output? If yes, can I get input? Can I input HRTFs to make them binaural, or as an ambisonics recording? So you can get the room impulse response out. You can download the results package in the results. Yeah, in the results module, when you're doing the comparisons there, you can download each source and all the impulse responses that are generated as part of the simulation. So you can get those. You're getting them both in mono and you're getting in second order ambisonics format. So it's not really possible to convolve your own, at least not inside of the Treble tooling. But you can of course do whatever processing you need to do on the other side of this, using other tools to then do these custom HRTFs. Of course, if you use the oralizer that's built into Treble, you get an HRTF model there, which is it's generic, but there is an HRTF model applied there in the oralizer that of course makes it binaural. But you can get the impulse responses as ambisonics and do it, and then kind of continue your processing from there. All right. So here's another question here. Are there more professional lidars available for larger rooms, and what is their price range compared to an iPhone? That's a question for you.
Yeah, I cannot answer that because I haven't used them. So yeah, I know there are others. I do not know what type of file you receive, like what format it is and how you can convert it afterwards, because we have to remember that for Treble, we need really simple models. Yeah, it's always up to us to make it simpler. Yeah, because we know that the very complex models it needs a lot of time to calculate them. So it's good for us to have this power to simplify it even more. So maybe you can use more complex scanners, but they will give you complex geometry and you will spend a lot of time to make it simpler. Yeah, that's out of my perspective, but maybe it is a road that we have to follow to go through it and see what it is, because not every single possibility we have. We haven't tested all of the things that are possible yet. Yeah.
And here's perhaps a somewhat related question to that, but maybe this is something I should answer. What is sufficient level of detail for a geometry? Let's say a space has HVAC ducts in the ceiling, and it's rather full of cabinets and tables, etc. So from my perspective, this does depend on what is it that you're trying to model in the space. If you have some very specific, you know that you're going to put your effective acoustic treatment in the ceiling, you will need to deal with these HVAC ducts in some way. I wouldn't probably put in like the full model of every screw on these things, but you can definitely put in some surfaces and put in some simple geometries to kind of exchange them for the more kind of realistic geometry. And then again, if you're just doing a very low frequency simulation in the wave-based part, it very much depends on which transition frequency you choose. So if it's a very low frequency simulation that you're interested in, then the wavelengths at these for example 200 hertz or 250 hertz is quite long, and then the HVAC ducts doesn't have that much of an effect. So maybe it can be simplified somewhat. But a general rule of thumb in our case is like we usually say like 10 to 20 centimeters for a general analysis. Things that are smaller than that, try to simplify it, and then try to keep more geometry in there. Try to model the geometries as is when you're doing wave-based analysis, because the scattering is not applied, and you cannot compensate for rough surfaces in the same way as you can with geometrical acoustics. And as you saw, the kind of tables and chairs and these kind of thin objects, we really encourage you to try to collapse these into thin surfaces. So something that doesn't have a thickness dimension. That's going to give you much faster simulation times because you don't get these small objects. Do you have any comments to this also, Pavel?
Yeah, from my perspective and these LiDAR scans, as you've seen, the cabinets, the desk, the chairs, they are like rectangular objects, and you always have to adapt it afterwards, like to recreate this model for your purposes, like to delete some surfaces and to add some surfaces even, because you have seen, like, especially when it comes to ceiling, when you have something different in the ceiling, you've seen this sport hole. I had to add this construction beams, because they weren't scanned, because LiDAR scans in this iRhino 3D app, it doesn't scan or draw the ceiling and the windows and doors. All of those you have to do by yourself. But it's not so complex, but you just need to do that afterwards.
Additionally, I can maybe reveal, like, we're working on some case studies these days, and one of them is exactly about this kind of what level of geometry should you do for Treble. And one of the things we found in our studies there is that, for example, when you're dealing with a window, and you've modeled in geometrical acoustics, it's very often that you draw the wall and then you just cut out a piece which is the window. But in some cases we found that, when you do this with the wave-based analysis, you will be very often getting flutter echoes between walls that kind of creates these two-dimensional sound fields and a bit too high reverberation time. But as soon as we simply just extrude this window sort of into the frame of the window and get this level of detail in there and kind of break up the sound waves, then we get a much more realistic and kind of as measured reverberation time. So wave-based does require you to put a bit more details in, but you also get much better accuracy out of it, essentially. All right. On to the next one here. Some BIM models on our projects have hundreds, even thousands of rooms. Is there going to be a way to import a narrowed model with only spaces of concern? So that's one of the things that we really would like to kind of explore in this beta version here. So I encourage you to sign up and try to, once we have this live, try to put it in and see what comes out. If you have thousands of rooms, I think it's going to be a long list to scroll down, at least once the processing has finished. But I could imagine that we would like to be able to input some kind of scoping, whether it's like a bounding box or that you as a user or your collaborators should try to scope it more towards a smaller section of the space or of the building. Sorry. Yeah, so good question. Great question, actually. And I hope we can answer it quite soon. But, in the ideal world, when I'm talking about this, like a little bit kind of further vision of future vision, then ideally, yes, you should be able to import whatever building you have, and you should be able to do analysis in bulk on, buildings with thousands of rooms. And you should be able to figure out just almost instantly where are the problems in this huge building, so you don't have to kind of rely on gut feeling, essentially, on where the issues are here, because the issues can arise in small places. All right, I hope that answers it and encourages you to also sign up for the beta. And here is another one here who tried to submit the form. I hope that you got your submission through. Otherwise, we'll be sending it out with the let's see if it went through. Yeah, it went through. So we'll be sending out the form in the follow-up material. All right, here's another question about to Pavel. Can the simplification work made by Pavel in Rhino be done automatically using the IFC import process and automated simplification later? Or maybe that's actually for me. I hope.
Yeah.
I hope so. Like that would be the ideal, and that we would build some tooling that comes at the end of the scanning process, so that Pavel can save these 20 minutes of removing and trimming down surfaces, so he can just go straight from scan to assigning materials.
Yeah, if I can add something to here, those, as you see, those scans are not so perfect when it comes to interior. So you always need to adjust something, yeah, like the table or chair or something like that. When those scans will be more, like more real, maybe then it won't need the time to do this adjustment afterwards. Yeah.
Mm-hmm. Fantastic. Yeah, so that's an exciting route to look into as well. Like this data collection, to kind of building workflows around this, so that so you don't have to couple together 5 different plugins to get your simulation to work. Next question here is about Blender BIM. What about an add-on to Blender BIM? Will there be a Treble plugin for this? So this is not something we have scoped out yet, but one part of the future here is to be able to plug into these different environments. One interesting thing here would be that we have an SDK available for Treble, even though it's not yet fully rolled out to everyone. But that could be an interesting project for perhaps for you to look into to integrate the Treble platform essentially through this. And if you can export an IFC, you should also be able to get this into the Treble platform, either through SDK or directly with this manual step. Okay, next one here. Can artificial intelligence somehow be incorporated to create and simplify models? And I think that's a very exciting question, because like AI is everywhere these days, and you can get everything from whatever you answers to whatever, and we have been looking into some this technology in exactly this kind of creating and simplifying models. So one of the things we've looked into here is the ability to create IFC models from plant drawings. So kind of filling in the gaps or interpolating so that you get a 3D model out of a plant drawing. And I think this is something that we will see in the future, and also being incorporated into the Treble tool. I hope so, so that you also don't have to, when you only have a plant drawing, then you also don't have to go through the hoops of drawing it up like this. All right. But in terms of kind of creating models, now you can of course get text output from AI, and you can also get picture output, but I don't see why the next phase is also to get 3D model output from prompting. So I'm sure that this was just something that we will see in the coming years, if not even months, that these types of things will emerge. I haven't seen it yet. All right, next question here is, can I display room modes in Treble? And I would say the answer is it's yes, kind of. You can create these surface receivers, and you can see the octoband results here, and which will give you some kind of idea about the modal distributions of a space. We would like to expand on this so that you can see more narrowband results in the results, and I think this is something you will see coming into Treble in the not so distant future, without revealing too much here. Here's a question for you, Pavel. In the T20 results you showed for the large office, there were slight differences in the middle range. Any guesses why?
Yeah, I like this question, because when you start to compare your simulation with the real measurements from the real life, you see that the simulation cannot fit like 100% to the real life measurements. Why? Because we do not know all the reverberation coefficients for all the surfaces in our rooms, like for 100%. For those I measured, we had really good sound absorption coefficients, because those were mostly our products, yeah. So that's why we had them. But for some surfaces we didn't have, like for windows, maybe it was this one, but maybe this one fits better, if you know what I mean. So we were not 100% sure. We are choosing the, let's say, 100% perfect sound absorption coefficients. That's why. And yeah, it's really good to work with the real measurements, because we see where we do mistakes when it comes to sound absorption coefficients, if you know what I mean. Like it is good to work with them to learn which type of the surface I need to choose, and what scatter coefficients also I have to choose. Yeah, it is up to your experience, and step by step, project by project, you will make even more precise projects, like more precise simulations. Yeah, I can assure. But yeah, when we see ourselves from the very beginning, yeah, we have made a lot of mistakes at the beginnings, like, you know, the not proper sound absorption coefficients, not proper scatter coefficient, etc., etc. But you learn step by step, and I know I cannot hit like 100% real life measurements. It's obvious, yeah, like I cannot. But the difference you've seen on the chart was like 0.1 second. Yeah, it's really small difference, I think, when it comes to that. And those results we have received were very accurate, and we were very happy about them. Yeah.
That's a very interesting point, Pavel, that you kind of, you know, that this is like a learning process, of course, also how to set these simulations up, even though there are, you know, of course, like general guidelines for it. But by having a process like the LiDAR scanning, for example, you know, you can actually quite easily do these experiments. Like when you go out and measure a space, it's perhaps not that much extra effort to, you know, whip out your phone and do a scan. And if you can get to a model in about an hour, you know, this kind of shortens the feedback loop of also kind of having this modeling approach with you, and you can then, you know, from this you can get to a point where you can really be very efficient in your modeling.
Yeah.
And I would say, kind of from my experience, you know, one thing is to get the absolute things right. That's important, of course. But an equally important part of doing modeling is when you're doing these relative simulations. So when you're checking out what is the effects of you know, me changing this surface, then even though you maybe didn't get the exact coefficients of the gypsum walls correct, you would be able to see still what is the effect of some other surface inside the space, kind of switching this out or placing something in there. So you can use measurements and simulations in kind of in unison to get a very informed decision or recommendation about what to do with the space.
Yeah.
So that's a all right. Another question here. We only have just 5 minutes left, so let's see. And there's only also a couple of questions. So I think this seems to fit very well. But, you know, if you have more questions, please just throw them in. Just type them in here, and I think we'll have time for most of them. All right. So when we do import IFC models, will they be bucketed into floors or some kind of sorting to compare and analyze results? So we haven't developed this part of it yet, but that has been some ideas that we have been floating around. And as you probably know, you know, then these IFC models are usually kind of built up in these hierarchical relationships where you have the building floors, like the building stories, as I showed in the preview before. So this is something that's fairly, I would say, simple to do. So definitely something we should explore. And great to get this feedback. Thank you. All right. Let's see. I thought there was one more question in here. Let's see. So if something got voted up, it might end up. Oh yeah, here it is. So when the SketchUp plugins import the model into Treble, which format does it use? We tried OBJ and DXF, and it failed, but the direct import via the plugin worked. So when you're exporting things from SketchUp, then we're using this native connection between Treble and SketchUp. So we're extracting the geometry directly, and then we're putting it into Treble. I'm not sure I can exactly answer what went wrong here, but I encourage you to use our live chat to get some, you know, then we can look specifically at this case, what went wrong, if there was a bug or if there's something that needs clarification. So please don't hesitate, and that also goes for everyone out there. Please don't hesitate to use the in-app chat functionality, and you should get help within a few minutes if you have some questions.
Yeah, I agree. Yeah, I confirm. Like, we are using live chat a lot. Yeah, like at least once or twice per week, and yeah, it works very efficiently. Yeah,
that's good. That's great to hear. That's great to hear. And I'll bring it forward and give some pats on the back here that the guys are doing a good job on that. I hope you guys agree. All right. So I think we've actually gone through most of the questions, if not all of the questions here. Let's see if you have more questions. We still have 3 minutes, but if you have any closing remarks, Pavel, on your part.
Yeah, it was great to be here together with you. It was great experience. Yeah, thank you for inviting me, and I'm really proud to be part of this, and I'm really proud to use Treble, yeah, and share my experiences. That was pleasure. Yeah, thank you.
Yeah, thank you very much, and likewise, Paul. It was a pleasure having you on, and kind of we're just so happy that you're willing to share your experiences with this, and please, if anyone has any other experiences, or you've tried the LiDAR scanning, I'm sure you would like to hear about it, Pavel, and just kind of share some experiences with this. That would be super cool. So I don't think we have any other questions popping up here, so I think we're just gonna call it a day. And I would like to thank all of you for asking questions and being interested in what we're doing here at Treble. And yeah, thank you very much.
Thank you.